do X-linked pedigrees and genotypes. So we're going to do a sample pedigree. Let's do a pretty generic one. So we have grandparents. I'm making this real generic here. Okay, so let's do... We're going to make this family. You know, I will say sometimes in building these case studies, I think, good Lord, what are the odds of this many couples having two people with family histories of the same genetic disorders? Pretty rare, but I'm concentrating the pool just to make these good practice. Oh, this is like the case of the student I had a number of years ago that I told you about. Okay, so we have a pedigree here. This is a family with a concentrated history. We'll say this is color blindness. Okay, it doesn't matter what it is, but remember there are two alleles, and whoops, what did I just do? Woo, that was bad. Two alleles, and they're both on the X chromosome. There is nothing on the Y chromosome. Okay? There is no gene for this on the Y chromosome. So, males get, well, first of all, we know that this is a male, so he's XY. Can we tell which X he has? This is multiple choice. He either has X big N or X little n. X big N, because he's unaffected. Actually the easiest way to approach the genotypes in the X-linked is to look at all the males first. Why? Because the males are easy. Ha! Get it? Look at all the males first. Why? Get it? Males, why? I thought it was clever. Whatever. So, I'm going to tell it to my husband tonight over dinner. So, this guy is XY. Can we tell which X he got? He's X little n. So I'm going to go through and I'm going to identify the genotype of every male in this pedigree first. So here we have somebody who is XY. Which X did he get?
Little n.
Little n, because he's affected. Here's another guy, another XY. Which N did he? Which X N did he get? Big or little?
Big.
Big, because he's not affected. We're doing color blindness. Okay, this guy, XY, did he get the X big N or the X little n?
Little n.
Little n, because he is affected. He is colorblind. Okay, what about this guy?
Little n.
X little n. We have we've got a few males we've missed over here. We have XY and XY. Whoops. Yeah, those guys are both big M's. Okay. Now, have we gotten all the males?
No.
Oh, that guy. Okay. Which one is he? X big N or X little n?
Big n.
Big N. Because he's not affected. So once we have all of the males' genotypes in there, the easy thing to do now is that we can start identifying their mothers. So once we have their genotypes, it's really easy to tell what their mom's genotypes were. So for every male who is an X, well, first of all, we know all the ladies' None of these women are affected, so they all have one copy of what? X big N. So we can go through and do that. Oh, I should have kept those in red, huh? That was a good little system. We know that each one of these females has a big N because they're not colorblind. Oh, she's going to be hard to write in a genotype for, isn't she? You got them all? Okay. Now, for every female who has a son who is affected, what does that tell us about her other copy of an X? It means she's a carrier, because she is where her son got it. So we know that this one is a carrier. Huh? If they don't have a son, there are. We'll get to that in a second. We'll get to that in a second. Question.
That one female at the bottom right doesn't have it.
Oh, you're right. Sorry. We know she's big N. Okay. All right. So if they have a son, because the question was, well, what if they don't have a son? How can we tell? There's a way to do that for some of them, not all of them. If they don't have a son, we don't know for sure, but if they, so where are other females who do have, oh, here's one we missed earlier. And she has an affected son, so we know she has that. Okay. We know that this female has that. Do we know for sure this female's genotype? No. Okay. She has an unaffected son. Does that mean that she's not a carrier?
No.
Okay, Bailey Schaefer's shaking her head no. Why not?
She could be a carrier.
Okay, and just luck of the draw, it's a 50% chance she's going to pass on that affected X to her son. So a carrier female could have 10 unaffected sons. Doesn't mean she's not a carrier, it just means, the genetic dice rolled the right way every single time. Okay, for females who don't have offspring, but we still want to know their genotype, can we tell her we don't know what her genotype is. That's going to remain a mystery because she doesn't have any affected sons and we don't know anything about her parents. For this female here, can we tell what her other X is? How many of you would say, yes, we can tell? How many of you say, no, we can't tell? How many of you are true chicken to commit to a position? You say you can? Why can't we? Can. We can tell absolutely 100% what her genotype is. So you can get genotype information in a case like this by either looking at the offspring or by looking at ancestors in some cases. Where did she get that X with a normal N? Her mom. Because her father only has one X, and what does it look like? Little n. She is guaranteed a carrier. No way out of it. She's a carrier. Because she had a colorblind father. My daughter will be a carrier of colorblindness. If she has a son, there's a 50% chance that he would be colorblind. So, yeah, we can determine her genotype. Is there anybody in here whose genotype we can't determine? I see 2 females right now who we cannot determine genotype on. Are they in generation, we've got generation 1, 2, 3, and 4. Where?
4.
Generation 2. These 2 sisters. We know their mom was a carrier. What are the chances that they're carriers? We can tell. Well, we can give a percentage chance. So let's do a Punnett square for that. We have an X big N, X little n, carrier female, reproduces with an X big N, Y male. So we don't care about the male offspring right now. We're not even going to do the Punnett square for them. We're just looking at their female offspring. There are two possible genotypes for any of their female offspring. What are the chances that those two sisters are carriers? 50%, yeah. 1 in 2 chance that they're carriers. So, you know, could they be carriers? Yeah, they could, but we won't know. The only way we would know for sure that they were carriers is if they produce an offspring, a male offspring who's affected. Okay, does that help in terms of identifying genotypes for the X-linked stuff, X-linked pedigree? Okay. These are actually, once you get the hang of it, it's a lot simpler, I think, because there are fewer options. Because the male or female already cuts your options in half. There are only 2 genotypes for each of those. Other questions, other comments, other concerns? You're going to keep working on these while I float around and help, or rather, you know, pop around like a piece of popcorn in a tornado?